Hi, I'm Miss Hearn. Let's get started.
The last measure of center is the mode. The mode is the number of times a data value occurs. So often it's just a matter of, it has to do with the number of times a data value occurs. So you're just counting the number of times each data value occurs, and the one that occurs most often is the mode. Yes, it is. So guess what? If you are given the data in a frequency distribution, that's the easiest way to find the mode. Now, it is possible for two data values to both occur with the greatest frequency, in which case we will say the set is bimodal. If more than two data values occur with the same frequency, same greatest frequency, we call it multimodal. Some books just say there's no mode. If more than two data values are occurring the greatest number of times, it kind of gets meaningless a little bit. So in some books, especially if you took MGF 1106, Foundations of Mathematical Reasoning, you may have learned that if it's more than two modes, that it's no mode. But in this book, they say it's multimodal. And they reserve the expression no mode for when no data value is ever repeated. They're all unique. Okay, so those are definitions you'll need to know. What would be the mode of this set of numbers of siblings then? So 3 occurs how many times? 4 times. So that would mean that the mode is 3, and it's only got one mode, right? Now, when you're doing this in a small set, you might not make a mistake if you leave it like this, but you might want to rank them if it starts to be a little bit bigger, or make a frequency distribution. How about set A? 1.10. Good, 1.10 is the mode in set A. Or were there 2 in A, or are you talking about B? Okay, B. B is, 27 and 55 each occur 3 times. That's the most that any data value occurs. Bimodal. When it's 2, we call it bimodal. And the answer is 27 and 55. And how about the last one? No mode. Good.
So in B, if it was 3 88s, then it would be multimodal, right?
Say that again?
Like if in example B, if there were 3 88s,
Mm-hmm.
then it would be multimodal?
That's correct. If, say, there was an 88 instead of a 99 there, it would be multimodal. Okay, so given the frequency distribution, how do we identify the mode? Because we want what? The data value that occurs the most times. What occurs the most times in this frequency distribution? 5 does. Very good. Common error on the test is to put 8, because again, you get in a hurry and you're not thinking about it. But so be careful. Make sure that you're actually giving the data value and not the frequency. Okay. All right, so some advantages of using the mean as your measure of central tendency. For reasons that we'll talk about later, when you take a sample from a whole population, the mean tends to stay close to the mean of the whole population. If it's the population, then it definitely takes every data value into account, and it tends to, even when it's a sample, stay close. So that's one advantage of using the mean, and we use the mean a lot. But as I mentioned before, it is very sensitive to every single data value. If there's one extreme value, then it's going to throw it off a bit. That's the advantages and disadvantages of the mean over the median or the mode. Okay, there's another measure that I want to mention called the midrange. We do not use it very often, but it is a term that you need to know. It's the value midway between the maximum and minimum values in the original set. So you add the maximum value to the minimum value and divide by 2, in other words. Now the mid-range can really be very sensitive to extreme values, and like I said, we don't use it very much, but just so you understand what it is, how would you find the mid-range of this data? That's right. So the highest, I ranked them just so you could see it more clearly. The highest number is 5.40. 0.42 is the lowest. So we're looking for the number halfway between those two. Not the position, the actual average of those two numbers. So if you add those together and divide by 2, you get a mid-range of 2.91. Okay, notice that the mid-range is way, if you were to put it among the list of data values, it'd be way over here, right? And that happens because that 5.4 is so much greater than the other values. So this is one reason why the mid-range is not used a lot. Remember that the median, when we calculated the median of this same data set, it was 0.915, quite a bit different. But if I told you there's a data set that has a median of 0.915 and a mid-range of 2.91, you could you would have some information about that set. You'd probably realize that most of the data values are smaller and that something threw off the mid-range. Which is more representative of the data? The median, right? Okay. So mid-range, very sensitive to extremes. Why do we even bother talking about it? Well, it's pretty easy to calculate, right? And we want to reinforce in this section that there are many ways for a person to think about what's a middle or representative or center value of the data. And finally, just so people don't think that it's the median, we give a name to what it is, what that means when you take halfway between the smallest and largest value. That is not the median, that's a different value altogether, called a mid-range. Okay, so when you're rounding off mean, median, mode, and mid-range, you're just going to carry one more decimal place than was present in the original set of values. Now, my stat lab is usually pretty good about telling you exactly how many decimal places, but this is the general rule of thumb.
I hope you found this video useful. If you did, please remember to like it.